So one type of solution stoichiometry problem that we have are called titration problems. Now, titration problems can be used to help determine the solution stoichiometry if we're talking about a precipitation reaction, like in the previous example that we looked at, or what's called an acid-base neutralization reaction, or an oxidation reduction reaction. In this instance, we're going to look at an acid-base neutralization reaction, and what we're going to do is to, given a certain amount of our acid, nitric acid, we're going to determine just how much of the calcium hydroxide base would we need in order for the acid and base to neutralize each other completely. So let's start out by assuming that we have 50 milliliters of a 0.1 molar nitric acid solution. And what we want to do, as I said, is to figure out just how much calcium hydroxide would be necessary in order to completely neutralize that nitric acid solution. So in order to do that, the first thing that we need to do is to determine just how much of the nitric acid is present. And because we have a solution, we need to take the volume of that solution that we're adding, and we need to take that in conjunction with the actual concentration to figure out the moles of HNO3. So once we have that, now we're ready to use our mole ratio from the balanced equation. And now that we're in moles of calcium hydroxide, now we can use the molar mass of calcium hydroxide, which is 74.10. Now that we have our setup, we can do the calculation, multiplying across our numerators, and our only denominator of consequence is the 2. And when we do that, we should come up with 0.185 grams of calcium hydroxide, excuse me. And again, another way of expressing that would be 185 milligrams of calcium hydroxide. So again, with solution stoichiometry, whether it is calculating how much reactants you need to produce a precipitate, or to neutralize an acid or a base, or in an oxidation reduction type reaction, the first thing that you need to do is use the solution volume and the solution concentration to determine the moles of the reactant. And from there, it's your typical stoichiometry type problem with the mole ratio and then the molar mass at the end.